statements that you'll use for your proofs, like the reasons. These end up being reasons. Okay. Addition property is simply if A and B are the same and I add the same thing to both sides, they're still the same. Right? So if x equals 3, x plus 2 will equal 3 plus 2. Okay? As long as they're equal, I can add the same things to both sides and they're still equal. Okay? Subtraction, same kind of general idea, except we subtract from both sides. So if x equals 6, then x minus 4 is equal to 6 minus 4. Okay, so I can add or subtract the both. We use this property or these properties when we're solving equations. X plus 3 equals 7. I subtract 3 from both sides to find out what x equals. So it's just a property of subtracting the same thing from both sides or adding the same thing to both sides. You have multiplication, same thing. X equals 2, well 3x is equal to 3 times 2. I multiplied the same thing to both sides. And division, if x equals 5, then x divided by 5 is equal to 5 divided by 5. Okay, so hopefully those properties, not so bad. Just what did you do? Did you add, subtract, multiply, or divide? That's your property. Okay. Here's where they get a little bit more complicated. Okay, but I have ways to help you to remember. The reflexive property. We use reflexive property to introduce new things into a proof that aren't already there. And you can say, like, you want a 5 in there. So you go 5 equals 5, reflexive property. And that's you justified throwing something in there that wasn't there before. And the way you can remember reflexive property is it's like a reflection. It is the same thing on both sides. A equals A. 5 equals 5. A side, QT, or equals QT. As long as they're identical, it is the reflexive property. Okay? Symmetric is an if-then that flips. If A equals B, then B equals A. And we use this to rearrange things across the equal sign. That this is the property that allows us to flip across the equal sign. Okay? And it's symmetric because both sides are equal, right? If you have symmetry, you have two sides that are equal. So that's how you remember symmetric is both sides are equal. Okay. Transitive is a transition. We transition from A through B to C so that we get A equals C. Transitive has a middleman that you transition through. Whenever you see transitive, you will have this situation that's not showing up very well. Hold on, let me highlight it. This situation. That's terrible. B and B, 5 and 5, X and X. You always have the same thing on either side with an and in the middle of it. That's how you know transitive. And you're transitioning from A through B to C to get A equals C. Now for substitution, this is anytime you replace one thing with another. I can substitute 4/4 for $1. They have the exact same value, but maybe I need quarters, right? So I can substitute them. So that's all substitution is when you replace one with another. So all this junk right here is a fancy way of saying I took one thing out and I put something else in that had the exact same value. So, so if x equals 2 and x plus 3 equals 5, then 2 plus 3 equals 5. I took the x out and I put the 2 in. Okay, so anytime you take one thing out and put another thing in, you've done a substitution. They do substitution on sports teams, right? Where they take a player out and put a new player in. Right, substitutions, same idea. Commutative, you have your commute, your morning commute, where you go back and forth. So you go from home to school and then school to home. So all you've done is change directions. So commutative is just a commute. And when you commute, you change directions. Okay, so A plus B is the same thing as B plus A. All I did was flip them. Right? So you flip the numbers or values or whatever. Okay. Associative. Associations are groups. Okay, so A plus B plus C in parentheses is the same thing as A plus B in parentheses plus C. All I did was move the parentheses. That would be like in this classroom, I could have you guys group. I could group, like split in the middle and have this group and that group. And you have however many people are here right now. I don't feel like counting. Or I could split you by girls and boys and you have the same number, right? It's the same value. It's just a different group. And then distributive is where I give this A to the B and the C, and this is multiplication. And I am multiplying in. Traditionally, or I can distribute out, which is multiplying out, or like dividing out actually, not multiplying out. So when I'm doing the distributive property, I'm either multiplying in or dividing out. But those are both considered distributive property. Okay, so here I'm multiplying the A in, and here I'm taking the A out. And if you want to try to remember that one, like if I distribute little blue squares, I distribute them, I give you each one. So I distribute this A to everything in the parentheses. Okay, so just to recap the stuff I didn't record, inducing is making conclusions based on pattern observation, and deducing is going from facts to conclusions. Okay, so we solved this equation. You guys are good with the solving? All right, so now we're going to write a proof. Okay, our first step of a proof is always given. Sometimes more than one step is given. But whatever information they give you, the reason is given. That's always the first part. You always write down given statements first. So when you're doing a proof, you better get this part right, because that's always the first step. Now the next step, I had distributed in that 3. So the reason is distribution. Okay, the next step, 3x equals 9, because I subtracted. And then finally I get x equals 3 because I divided. Or so I write division, not divided. Division is my reason. And then at the end of a proof you write QED, which stands for Quod Erat Demonstratum, which means I showed it to you. I've proven it. What? That which was to be demonstrated. So you write QED at the end of a proof to show that it's done. The first proofs are already mostly done for you. Okay, that was given. We added 3. What did I do to get from this step to this step? So I'd write division. Yeah, so it's always to go from here to here gets written there. Okay. B, given, I substituted in, and then I added 4 plus 3, and then I did what? To get multiplication. It's to go from here to here. Yeah. So you're always writing from this step to this step, and then the reason goes down on this line. Does that make better sense?
Yeah.
Okay. This is given. What did I do to get from here to here? Yeah, but I multiplied specifically into a parenthesis, so it's distribution. And then I added the 16 plus negative 11. If you had written subtracted there, that would be okay too, because it's adding a negative or subtracting, that's fine. So to go from here to here, so I subtraction. And then to go from there to there, we did division. Okay, the first reason is always given. Then I added, and then to go from here to here, not division, it was already being divided, so I multiplied. All right, so got it? So the next thing, part 2 question, or question number 2 for the blue square.